I'm Oliver Gutfleisch. I'm a professor for functional materials in the Faculty of Material Science at TU Darmstadt. Functional materials are part of future materials. Materials have defined political and technological, social, human developments. So future materials will be very important for fundamental global challenges of our society. Our group here in Darmstadt, the Functional Materials Group, looks mainly into the development of modern magnetic materials. Every person in industrial society owns at least 50 magnets. So the research challenge for us in the group here of functional materials is that we need to develop resource-efficient new permanent magnet materials. We can make our high-quality magnets on our own. The elements are stored in the glove box in its high-purity form. We choose the standard traditional ferromagnetic elements like iron and cobalt. We mix these elements with the lanthanide series of the rare earth elements. These elements are then molten together in an arc melter. There we try to form the alloy, means a right mixture of different elements. After having produced the alloy by arc melting, we need to homogenize it. Exposing the alloy to simply high temperature in air will lead to a very rapid oxidation. To prevent this, we seal our alloy in a quartz tube and have a high temperature anneal, what we call homogenization. Now we need to make the magnet. We build it from a lot of elementary magnets of little units which we need to produce by pulverization. Our rare earth containing alloy reacts strongly with hydrogen. We have a very substantial lattice expansion. So we have a very large internal strain induced into the material, which results into the decrypitation and powderization of our material. We have now produced a very fine powder. We need to consolidate. Consolidation takes place in our hot press. TU Darmstadt and the Material Science faculty has very strong links with industry. We use these links to have placements of students for internships, for practica, so that they have hands-on knowledge and experience in industry for our topics here taught at TU Darmstadt.
Hello, my name is Tino Gottschall. I'm a PhD student in the group of Professor Gutfleisch, and in the next couple of minutes I want to explain to you what is the task of the week for future materials. So the task is divided into 3 parts, and the first part will be about a small experiment where you need to build a simple motor on your own. The second part is just from a practical course for students where the topic is characterization and analysis of magnetic properties. And the third and last part is a short essay where you should investigate a topic of your choice. But first I want to explain to you what is the experimental part, the first one. So the idea is that you build a simple motor just from these components here. So what you should use is a battery, 2 paper clips, a copper wire, a rubber band, and most importantly, the permanent magnet. So from these components you can build a motor, and just to prove that it is actually working, I want to show you my motor. And indeed it is working. So the idea is that you build up your design, that you make a short movie, how the motor is moving, and that you upload it to the website. So this is all for the first part. The second part is about characterization and analysis of magnetic properties of 2 different materials. So on the one hand, we want to study a simple ferrite magnet, which you most probably know just as a normal refrigerator magnet or on blackboards. And we want to compare the properties with a modern neodymium iron boron magnet. Therefore, we have here this measurement device where we can apply magnetic fields up to 7 Tesla, which is very large magnetic fields. And the measurement is very fast because we just need to apply a magnetic field pulse. So what we do is we take our neodymium iron boron magnets and mount it to the sample holder. And just pull the screw a little bit. So now I put it into the coil where the magnetic field is applied, and now I just need to load the capacitor bank, and by this we can apply the magnetic field. So now I initiated the measurement, so the capacitor bank needs to load. This takes a little while, but as soon as it's fully loaded, then the measurement is very fast, and within 1 second the measurement is done. So it's now at 80%. So, and all information, by the way, you also find in the instructions that are also on the web page available, together with all data files. And now the measurement is done, and here you can see the MH and the BH curve, and from these two curves we can extract all important information about the magnetic properties, and this you will compare for the two materials. So in total there are 7 data files available on the web page, and you should plot these, and what exactly you should do is written here in the instruction. And the last task will be a short essay. So there you have a lot of freedom what specific topic you want to discuss. So the main idea is to speak about the role of magnetic materials for green technologies. So you, for instance, could speak about rare earth materials in general, or the recycling of these materials, or which specific technologies need magnetic materials to work properly. So the length of this essay should be about 2 pages, and please, as soon as you upload it to the website. Thank you.